So, hi, I'm Mikko. I'm right now working at Linaro, doing Yocto stuff there. And previously, I was for almost a decade in the automotive business in Germany, using Yocto a lot as well there. So in this talk, I will be mentioning how to detect and fix CVE security issues in the Yocto-based embedded Linux distribution, which was the work that I did in the automotive industry for a long time. These slides are originally for a security conference where people did not have lots of Yocto background, so therefore there's lots of introduction into Yocto as well, but I'll skip over those slides quite quickly. So in this talk, I will just show with introduction how to use the Yocto tooling to find CVE security issues and how to fix the issues as well, and some lessons learned when doing this work. The motivation is basically nowadays products which are connected to the networks, they need to be somehow kept secure so that the products themselves, that the data inside the products or in behalf of users stays safe in the product for a long time, at least for the lifetime of the product. And then developers need to be aware of what security issues are affecting their product and then decide what to do about those issues. And outside of the scope of this talk is how to actually deploy the security updates or in general software updates to the products and in general how to make products secure. I will mention a few other things as well, but this is not the only way to make secure products. Yeah, okay. Yocto, we all know, is a way of building custom Linux distributions, and by custom it means that the one who creates a Linux distro needs to also maintain it. There's some support coming from Yocto, especially in the LTS side, which you need to pull in. But other than that, you are on your own and you need to make it secure. Also with the security patches. Yeah, Poky is our reference distribution, comes with all bells and whistles. And there's a really nice community, and this is one of the community conferences that we're participating right now. Yeah, the layered architecture. Usually we start off by taking Poky, but for any real more complex products, we amend the Poky distro with lots of other stuff. We have BSP software layers, we have middleware layers, we have graphical user interface layers, we have other special purpose open source layers from the layer index, and we have these custom product and company specific layers. And usually these end up being tens of different meta layers providing recipes. And in some products, like I used to work with, we had more than 70 layers in the whole build environment. Yeah, shortly, what are the inputs to the build? I mean, the meta layers, Poky for starters. Then we have the basically configuration step of the build, which produces a Bitbake build configuration, and then we call Bitbake to do the build. Then also inputs to the build are the caches from previous builds, the download and state caches. And yeah, lots of CPU, memory, I/O, and storage space are needed for doing a build. And outputs for the build, I mean, all the binaries for the hardware, including kernel, initial RAM disk, root file system, but also what, in my opinion, should be out of the build output from the build is also flashing tools and scripts needed to work with the target hardware, an SDK to debug and develop for that hardware, package repository, and then metadata in the build history, and then also download cache for the future builds as well, so that we don't need to always download from scratch, and state cache as well, and also other data in the build/caches directory, which includes the PRSave database, so that you can get, for example, incrementally monotonically increasing binary package version numbers so that you don't need to care about the PR values in recipes on your own. And optionally, of course, SPDX, bill of materials data, CVE security scan reports, and so on. There's lots of features in the Yocto build environment. Yeah, and as we know, builds require lots of resources. Just maybe a short overview, what are the differences with Yocto compared to Debian Ubuntu? I mean, just in terms of compilation, Yocto builds everything, the full dependency tree of a change for the whole full platform. And Debian and Ubuntu, they usually build a single package at a time and then manually handle these transitions when APIs actually break. Yeah, and Debian and Ubuntu are general purpose. Their binaries have all features, or most of the features enabled, everything which is considered stable in their developer's point of view. And in Yocto, you can actually disable those things quite easily. And features include things like IPv6 support or SC Linux support, and you can usually disable and enable them using distro config and image config and so on, which in some cases turns out into recipe level package config variables. Yeah, Debian and Ubuntu have tens of thousands, if not even more, binary packages, and Yocto has considerably less, which is a good thing or a bad thing, depending on your point of view. Yeah, releases. Yocto releases twice a year, but there's also now these LTS releases, which are maintained for a lot longer time. And Debian, for example, releases every 2 to 3 years and maintains the previous releases for up to 5 years. Let's see. I hope that with Yocto, Dunfell, and Kirkstone, we also get up to 5 years of maintenance at some point from the community, even though that's not everything. Yeah, comparing to Debian and Ubuntu, Yocto has a smaller community. Yocto has maybe tens of really active upstream developers, tens of companies involved as well. And Debian has, I would say, an order of magnitude more developers. But on the other hand, in the Yocto community, there's lots of companies, hardware companies and SoC vendors providing their own BSP software layers and their tooling as per. But in the Debian world, these things may not exist. Yeah, and in Bitbake world, recipe is the source package. And here's an example that OpenSSL recipe lives in this location in Poky. And there we set the metadata for the recipe, the name, the version, and the license, and so on. And then eventually compile, and configure, compile, and install the software to produce a binary package. Yeah, and here's a snippet from the OpenSSL recipe from Poky, which has the, let's say, important bits and pieces for doing security scanning for the CVE security vulnerabilities. These are the CVE product. Also related is the CVE version suffix, which I will not go into details in this talk. And the second important thing is the CVE check ignore here. Yeah. Okay, what is then a CVE security issue? It's basically just a fancy name and an identifier for a bug which has some security consequences. Yeah, there's lots of definitions for it, but usually it has an identifier, and there are ways to get these identifiers for basically any bug report where the details are open. I think there are also ways to keep a CVE and the details hidden for a long time, and these are sometimes visible in the CVE database as well, and that you cannot always get into the details what this bug is about. Yeah. Yeah, so the CVE bug reports come from security researchers, developers, vendors, and whoever is contacting the CVE authorities to give an identifier, a CVE identifier for a bug, basically. Yeah, for open source, many bug finders to report them into public or private security mailing list or directly talking with the maintainers of various software components. Yeah, and sometimes these discussions happens with the discoverer of the issue and various vendors, and sometimes these vendors want to hide or silence the issue of this discovery. Yeah, and sometimes the vendors even pay researchers to find security relevant bugs. And basically how to get a CVE number for a security relevant bug, you just contact one of the many CVE number authorities, and there's a URL where you can get to those details. Yeah, then data fields of a CVE security bug. You have a description, you have a reference URLs, usually to Git repositories or mailing list entries or bug reports. You have the severity, the detail whether this is known to be exploited in the field, whether there's a virus or actively someone attacking systems with it. Weakness enumeration. This is basically a standard way of describing what kind of root cause does the bug have. Then there's the non-affected software configuration, which is the really important bit when doing CVE data analysis or CVE analysis with the Yocto build. this gives you the actual software product or software component name in the format of a vendor and a product. Yeah, and then there's a way to express the version ranges which are affecting, which the bug is affecting the software components. Yeah, and other matching criteria. Yeah, here is an example CVE for OpenSSL. There's a function with blah, 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 and it's affecting, the important bit here is the CPE, the CVE product, where the vendor is OpenSSL, that means openssl.org, and then there's software component OpenSSL. You quite frequently, these open source projects which use the same, let's say, vendor name and then their original big product is, they might actually have multiple products with various names. And then there's the version range. So this bug is affecting including 3.0.0 up to excluding 3.0.3. That means that the version 3.0.3 is not affected by this bug anymore. It contains the fix. Yeah, so the important thing to find out, or the requirement for the CVE analysis work, is basically how to identify software products. And here is a nice Twitter slogan from someone. There are two hard problems in computer science: cache invalidation, naming things, and off-by-one errors. That means that it's really difficult to globally name things systematically. And naming implies some kind of authority which may not exist globally. And for example, we might call OpenSSL OpenSSL, but someone might have a different name for it in their custom environment, in their software product, which of course makes things more complicated then. Yeah, the solution in the CVE space for this common naming problem is the CPE, the Common Platform Enumeration. It's basically means a software component in our use cases, but it can also be used for real platforms like Android. But yeah, in this example, we just used a vendor name OpenSSL and a product name OpenSSL. Yeah, the same problem as we had with namings, we also have with the versions. Most of OpenSSL users agree to use the upstream compatible version numbers, but that doesn't apply globally. Someone might want to call their OpenSSL with a different version number based on their own release identifiers. That usually then causes problems and the CVE checking fails. Yeah. Yeah, and then of course the CVE data itself, it's entered by humans, and thus there are bugs in this data. These bugs are in the reports, they're in all aspects of the report. The naming can be wrong, the versioning can be wrong. Yeah, everything can be wrong with the CVE data. And when there are bugs identified clearly in the CVE reports, it's best to try to correct them in the CVE database as well. This can be done either through email or directly contacting the CVE people from this web forum. They are usually quite fast in fixing issues in the CVE data. Yeah, and what is NVD? NVD is just a fancy name for the CVE database, National Vulnerability Database. And this is basically a JSON format database that can be downloaded from the servers. And this is what happens in the Yocto CVE scan build as well. Yeah, in other Linux distros, their users, how do they handle this? Well, at least for most users, when you have a Linux distro, you just blindly or almost blindly update your security patches from the vendors, and you're not maybe actively looking at what issues are currently impacting your build. But there are some tools for that as well. Here's one of them. But at least as far as I know, very few people are actually using this. It's better to just apply the updates from the vendor and think that things are clear with that. Of course, reality is different. Also, in the mainstream Linux distros, several CVE issues are not always fixed in time, and they may be open or affecting the distribution versions for a long, long time. But the issues might be so minor that the security maintainers of the distro say that they don't want to fix it, or the fix is too complex. Yeah. So coming back to Yocto CVE check. Basically, this documentation in the Yocto site was recently updated. I submitted some patches based on this talk as well and these slides. So what are the CVE security bugs that affect my software and images built with Yocto and Bitbake? Basically, to find this out, you enable inherit CVE check in your local conf when doing the build, and then rebuild your system. So what does the Yocto CVE check do? It triggers a compilation of some tools which can parse the CVE database. Then they automatically download a copy of the latest CVE database in JSON format. And this cached copy is kept, I think, fresh every few hours. It's going to be re-downloaded if the build is re-triggered. Then for every single Bitbake recipe, the recipe name or the CVE product and the version or the PV or the CVE version of the recipe, they are compared to the data matching in this for the CPE, which is the product name in the CVE database, and the version ranges for those bugs in the CVE database. And then if any issues are found to be affecting the version that we're building, then those are marked as affecting that software version. Then the Yocto patch metadata is also inspected to see if any CVE issues have already been patched or fixed. And then the CVEs can also be set to be ignored if the recipe metadata has been set this way. For example, and after an analysis which shows that the issue does not affect any Linux system, it only affects some Windows configurations running the software component. And then the report is generated for every software component that was in part of the build. And for every CVE, the status field is filled in, and the status is either patched, unpatched, or whitelisted, ignored. Ignored is the new new format to say. The whitelisting is the old stuff that still exists in some versions of Yocto and poky. And then also a report is generated for all the root file system images, which summarizes these data. And then the data is also in plain TXT format or as a JSON format from the output, at least on the poky master branch. And the JSON format is especially easy to parse with additional scripts. Now, then after the build, developers can browse through this data, these reports, and check which CVE security issues are patched, unpatched, or whitelisted in the product configuration. And then, they can still be, they can decide what to do about the data. There's still a lot of false negatives, false positives, and so on. So iteration is then required to basically analyze and redo the builds, and also then possibly fix the issues by either upgrading software components or applying patches. Then I have a couple of examples here to show how does the report output look like in plain text format. Here is an example from busybox. So basically what you get is the layer name, the package name, which is the source recipe name. Then you have the version that we set in either in the recipe or with the CVE version field. And then you have the CVE identifier, and you have the status, which is either patched, ignored, or unpatched. And then you also have a nice summary of the issue which also exists, and a link to the CVE database plus the CVE as a score. These are the, let's say, one way to analyze the impact of the possible impact of the CVE. So the higher the score, the more important it is to get this issue either fixed or resolved somehow. And then a similar report comes for all the images that were compiled, except that all the various source recipes which are part of the image are now compiled. The report for each of them are now compiled into a single file, so you can easily see all the issues that are impacting your image. So then a word about Yocto community maintenance. So like with all Linux distros, basically Yocto is also best effort maintained. I've seen developers don't have time to fix all the issues. And the non-LTS releases are maintained for up to 1 year after release. And releases are done twice a year, these non-LTS releases. And at least in my experience, that we were supposed to fix the issue in the Yocto world by using the so-called independent software vendors. But at least in my experience, these did not end up doing very good job in filling the security vulnerability gap. Then Yocto upstream runs weekly CVE scans, and results are posted to the mailing list as well as maintained in this patch metric page. So Yocto upstream developers are tracking at least the status of the CVE issues, but not necessarily fixing all the items there. Yeah, and of course LTS. Before we had Dunfell, there was lots of complaints from, for example, me, that Yocto is missing a long-term maintained release, but now there is, and I think, yeah, Dunfell as well is doing well. Dunfell and Kirkstone are both now in the open, still being maintained, but Yocto is still a relatively small community, and all the members who are using this are urged to also contribute to the maintenance, also with security patches to these branches. Yeah, so if you do find CV issues in your own product configuration with Yocto, I mean, first thing to do is to check what Yocto upstream in the Dunfell or Kirkstone branches, or in the short-lived or less the other stable branches have what Yocto maintains it there to fix the issue. It is, at least in my point of view, really important to have regular updates from the Yocto upstream into the product configurations. So basically doing git pull and git merge for your local upstream repos frequently. And then part of those updates may be the security issues also getting resolved, which may be important for your product and releases. Then how to fix the issues, of course, update or a patch. For every software component which has an unpatched CVE security issue, if the fix is to apply a simple patch, that's the way to do it, at least for the LTS branches. Then to update the software component to a newer version, which already includes the fix from the upstream developers, that's the way to go for at least the poky master branch. In some cases, yeah, okay, here's an example for the patch file. There's some patch formatting guidelines for it, of course. And for CVEs, what you need to do to make sure that the CVE scanning also detects that the patch has been filed, there's two things that are needed. One is to use the CVE identifier as the patch file name. And the second thing is to use it also in the patch file, into the commit message, which is embedded into the patch file itself. You need to have the CVE identifier. Yeah. And then once these are in place, the CVE checker will notice that actually the patch file for the issue was applied, and the status of the CVE turns into patched in the report output. Note that there's also the upstream status and so signed off by requirements for these patch files needed when submitting them to upstream. Yeah, here's a nice example for CVE 2022 30065. So it's use after free in awk. I think Russ was the one who submitted this. Good job. But it shows basically how to apply the CVE tagging into the patch file itself, as well as upstream status and signed off by fields, as well as links to the upstream busybox mailing list entry about the issue, and also the bug report that was used there. And the issue is a 3-line fix to some of the code there. Yeah, a word about the minor version updates to fix a CVE issue. When the upstream maintainers are good at providing API and ABI compatibility in the LTS branches, then those updates can also be done there. There are some good examples in the open source of some software components which maintain this API compatibility. For example, OpenSSL in the letter releases. In the numbered releases, let's say major and so on, the API compatibility is usually lost in some way. Another, well, maybe a bad example is, or where the API compatibility is not there, is, for example, glibc. When the version number for glibc changes, then it's likely that there are some incompatibilities and those updates cannot be used to fix a CVE security issue, at least in the stable branches. Yeah, and a word about ABI. So ABI is the API plus the compiled output through the toolchain. So depending on, yeah, there's lots of details about this detail. Yeah, let me just skip that. If anyone is interested in the API compatibility, there's also various tools that you can be used to check that and the output of an update. Yeah, so if CVEs can be patched, they can be unpatched or ignored. So basically, if you want to, after analysis, you want to set the CVEs ignored because, for example, it applies to a different operating system completely, so it doesn't affect Linux at all, it affects only Windows or OS X, then this is an example how to set the CVEs ignored. This variable is set in the recipe, and usually there's a comment in the recipe as well why this is set in such a way. I think these are then important to be removed when there's an update to the software component, which is, for example, supposed to have a fix for the issue as well. So when doing the, for example, update of Avahi to 0.9 or some newer releases, it's worthwhile to check whether the CVE check ignore fields variables should be completely removed. Yeah, okay. And of course, when support in Yocto upstream runs out and you're all alone, and you see the CVE bug reports piling with unpatched issues, one way to get out of the situation is to also do a full distro update to a upstream maintained release. Of course, these can be quite difficult in reality when you have, for example, those 70 different meta layers that all need to be compatible with the new version. But on the other hand, there are some, let's say, practices to make this pain easier. And Yocto, even though in Poky Master, Richard and others are breaking the compatibility quite frequently to be able to keep the system working as a whole, they are actually documenting the API changes quite well in the documentation. And this is part of the pain of just using open source. You need to be using somewhat maintained versions and being connected with the community via updates, or otherwise you'll be using a really old stale version and you need to do all the maintenance on your own and you cannot rely on the community at all. Yeah, one way to mitigate this pain is to really limit what you use from the various layers that you need to use for your product, and that's one way to hide things is to use the BP mask variable to filter out recipes and BP appends, which may be heavily version specific and which you might not be using in your product at all. Yeah, then into some problems with Yocto and CVE scanning. Everything can be broken, all the data can be wrong, so you need to verify everything. So policy, from my point of view, is trust but verify. Then to fix the CVE product related issues, for example, a report says that if you look into the details, that the same name for the product is also used in the Bitbake recipe in the open source community and Yocto side, but also into some custom vendor-specific product, which is maybe not open source at all. And therefore, the fix is to use the CVE product field in the recipe so that it matches the actual open source product. You may need to find out what is the open source vendor name there and the product name and use that combination. Yeah. And same for the CVE version. Sometimes the recipe version, which is the default, does not match into something which is used in the CVE reports, which is always referring to, or sometimes referring to, the upstream source component projects versioning, version numbers. And then sometimes those are not matching to what you use in your product configuration. For example, if you have some open source software coming from a Wi-Fi chip vendor, it may be that the Wi-Fi chip vendor has decided to rename or change the version number of your WPA supplicant recipe to something else which is matching to the Wi-Fi vendor's source deliveries and their versions, but doesn't actually match to the version that is used in the upstream WPA supplicant. And therefore, you might be missing lots of CVE-related fixes, or the reports don't show correct data for the version that you're using, actually. Yeah, another major problem is embedded source code. So some open source software components may be embedding into their build system lots of other software components, and these may be hard to detect. There are header-only libraries or even static binaries sometimes embedded there, and only an analysis of the software component builds may show up that they're actually using an embedded copy of Boost or OpenSSL. Sometimes these issues are visible if you do quite thorough licensing and copyright analysis of the software component as well. But sometimes even this doesn't give you enough details. So review of various open source software components is needed here, especially if they are not coming from the poky release, but maybe some less used software components in the Yocto community. One example, or not so good example, is Node.js, which in the default configuration is embedding a whole bunch of stuff, and they're even doing updates of those major version updates of those software components in their point releases, in their stable release branches. Yeah, another major problem with the CVE analysis work with Yocto is, of course, that if you don't compile the software, then you can't do any analysis on it. So if you integrate into your product lots of binaries from various vendors, then you may not have any idea what gets embedded into those binaries. There are media codecs that can be as binary into your product, and you cannot extend the CVE analysis, which happens at Yocto build time to those at all. It's basically a related problem which is in the software bill of materials work. So the license information and copyright information that you may need to have for those software components may show you some details that, okay, maybe there's actually also security issues impacting those binaries. One example which ends up in many products is the basically Chromium embedded browser. Various frameworks for various markets in the UI world also are embedding different versions of the Chromium browser, which is then also including lots of various other open source software components and versions which are embedded into the binary. Yeah. Yeah, and the CVE data can be wrong. Yeah, the product names and vendor names may be wrong. One example that I have here is the Android report. So security researchers are maybe looking at the Android build system, which is embedding some open source software components, and they're maybe even patching it and using it as a, they're using a different build system, for example, the Android specific one, not the upstream one. And some bug reports are therefore only showing in the CVE data that they are listing the Android specific versions only, and not anything that is actually related to the upstream version of that software component. Yeah, and one example where the naming is easily wrong is that, for example, curl and libcurl are the same thing, but sometimes the names don't match. Yeah, and incomplete CVE data. Some CVE database entries simply have incomplete or missing or old or garbage, let's put it this way. And for that reason, also in the poky default, there is extra include file, which has some default exclusions for CVE entries, which basically where the data doesn't make any sense at this time. For example, there's more than 20-year-old CVEs, which the data doesn't really tell anything, but it still lists that certain versions of software components are still being vulnerable. So it's a good idea to check into this file and maybe use it in your local build as well if you agree to the CVE extra inclusions, include file contents. Yeah, and disputed CVEs. So some CVEs entries are actually disputed. This is a status in the CVE, and it's quite visible also in the header of the CVE that the upstream developers of the software component, which has the security issue, have actually said, no, this doesn't actually impact the issue, or this is not a security relevant thing, it's a feature, or a user error. And usually these can be set then to ignored status. It might take a long time for the CVE data to actually show a state that the CVE doesn't actually mean anything. Yeah, naturally, patches can be bad as well. They can be wrong, they can have mistakes, they can actually cause more security issues than they were trying to resolve. So just applying the patches may not be the only thing to do to fix security issues. Yeah, and sometimes these issues take really years or even decades to fix. But the issue might be such a minor one that the upstream developers say that it's not really a disputed thing, but the issue is such a minor thing that they can ignore the issue. Yeah. Okay, another side of the thing is that the patches to fix the issue are way too complex. They, for example, are refactoring everything to fix the issue. And of course, that means that the refactored hundreds of patches cannot easily be applied to an older version. And the API and API compatibility may be completely lost with the patch set. So here I just advise that to follow what other Linux distributions are doing. For example, Debian has this really nice security tracker, which has the data which they use and fill in when they're doing CVE analysis for their whole distribution. And sometimes it's also possible, and what I really urge is to reduce the feature set that you have in your products to really completely drop the affected code parts and features which you are not needing in your product, as a way to fix also CVE security issues.
So we're at the end of time.
Yeah.
If you can move to questions.
Yeah. So
or
I
if you
just
want
have
to cover anything else.
Yeah. So just as Linux kernel is a special case. There's no accurate data at all. There's another way to handle the Linux kernel data, and yeah, there's no magic bullet solutions in the CVE security world. There's a whole bunch of ideas how to improve the security of products in the slides as well.